Okay, so now we're looking to move parabolas off center. No longer centered at the origin. That's what's tricky here. And this is our first exposure to that. They're giving us four different equations, which are really very similar, right? They all have like a 3 and a 2 and a 1 letters to the first power and the other squared and a 1, a 3, 2, and a 1. They all have a 3, 2, and a 1. And one letter squared, the other is not. And, and then they got these four graphs. One's going right, up, one's going right, but it's kind of down. One's going up and it's upper right, and one's going up but it's upper left. So it's mix and match. Which one's which one? Well, couple of things. Let me show you from it's all about the notes that will help us out here. Let me grab those notes for you. So grabbing the notes right here. So here's the whole direction thing. And then we need something else. We need to know about this right here. Which way they go. There we go. All right. So to figure this out, first off, let me jump down. This is on the notes, the exam 5 notes. Graphing a parabola not centered at the origin. That's what we're doing, right? We now have a parabola not centered at the origin. How do we deal with a parabola not centered at the origin? Well, step 1, factor out of 4. Got to factor out of 4. Okay, let's go do that. So right here, right, going to factor out of 4 from that. So that's going to become 4 times 3 is y plus 1, x minus 1 squared. We good so far? I factored out, what am I doing? That's not the right problem. Sorry, I'm getting totally lost. We'll do that problem later. I'm sorry, I am getting lost in my work. All right, factor 4. Yeah, it's true. In general, if you're going to graph, you got to have factor out of 4. But right now, I want to focus on the center because we're not doing the whole problem. We're just doing mix and match. So I'm not going to do that whole thing. I'm not going to worry about the 4 right now. I'm going to go here. Center is the opposite of the numbers next to x and y. So like, see, this is a -8, and the center is +8, and this is a -3, and the center is a +3. See how it's opposite, opposite? You see that? So, and that's the same deal we had for the ellipse and the hyperbola. That's the same deal we've had all semester long. If you're graphing something and you're looking at the equation, it's always the opposite of the number next to x and the number next to y for the center of whatever you're working with on a graph. It's always the opposite when you go from equation to graph, isn't it? No big surprise there. Okay, so let's get back to it, get to the right problem and stop doing the wrong problem. All right, so that means the center is opposite of this and opposite of this. So the center, I'm going to write the center over here. The center on this one would be what? -3, -2. Okay, what about this one? Oh, they're being tricky. I didn't realize how tricky they were being. Yeah, I should add more to the notes. You have to get the squared piece alone. Yeah, I didn't realize they're going to be so tricky. I'm going to have to be more tricky. So what this should say, first step should say, I'm going to add this in later. Get the second power alone. Get the second, that should be step number 1. Get the second, whatever the second power, see this one already was, get the second power alone. So I'm gonna need to do that. Let's get the second power alone. So let's come back up here and see on this one. In fact, let me just, I have a lot of room. Let me take it over here. So y equals 1, x minus 3 squared plus 2. I got to get this piece alone. Get this guy alone. So what does that mean? Subtract 2 from both sides. Right? Gonzo, gonzo. This is y minus 2 is 1. Okay, good. So now we've got this guy alone. Now Now you can grab the x and the y and go opposite, opposite. So what's it going to be? 3, the x has to come first, plus 3, plus 2. That's the x and the y. That's what? The center. So that's the one. So the second one, that I've only done the second one so far, and the first one. I've done the first and the second. So let me hold up for a minute. Let me start identifying. So I did the first one, and his center is -3, -2. Well, here's one right here whose center is -3 plus 2, right? That's back 3 up 2. This one here has a center back 3 down 2. And this one has a center back 3 up 2. This one has a center over 3 up 2, right 3 up 2. Okay, so only one of them, notice only one of them has a center back 3 down 2. So that's got to be the first one, right? So that's got to be B right there, this guy, right? So that was easy. The second one has a center +3 +2. Well, there's only one of those also right here. So that's got to be the one that's +3 +2 right here. So this one has got to be C, doesn't it? Because the center is +3 +2. Okay. And now I'm going to grab the next equation right here. Maybe I'll just move him over here. So we have x + 3 is 1, y - 2 squared. Notice the squared piece is already alone. He's in good shape. So what is his center? We're ready to grab his center. His center is -3 plus 2, right? Opposite, opposite, x, y. -3 plus 2. Now we have two of those. -3 plus 2 here. Oh, we've already done B though. It's got to be this one, doesn't it? Oh no, this is -2. I'm kidding, totally confused. -3 plus 2. There we go. I'm sorry. -3 plus 2 and -3 plus 2. We do have two of them. One of them goes up from -3 plus 2. One of them goes right from -3 plus 2. Right? Let me circle this one so I know this guy's done. Let me circle him with the same color that he got his answer on. Okay, B and C are done. B and C are out. Anyway, getting back to the problem here. So -3 plus 2, which one is this? Well, remember the direction thing. What tells us the direction the branches go? Up, down, right, left. If you look at the notes, look at the notes with you. It's all about the first power letter, isn't it? If the first power letter, because again, parabolas always have one side that's second power, one side that's first power. So the first power letter is the most important side. That tells you the direction. Positive x is to the right. If the first power letter is -x, that's to the left. The branches go left. If the first power letter, right, is positive y, the branches go up. And if the first power letter is -y is down, the branches go down. Okay, so what is ours? Let's come back to this one over here. This is the, let me circle, let me make things a little more clear here. Positive x to the right. The branches must go to the right, huh? See that? Because this is positive x. First power. Don't look over here at the second power side. Nobody cares about that. This does not determine the direction. Not the second power side, but the first. This is x to the first over here. This is the first power side. And it's positive. Positive x is to the right, right? It's like in the notes. Positive x to the right. Positive x to the right. Okay. So therefore, this one is going to the right. Which one goes to the right? Well, you think B does, but B's got the wrong center. It's A. He's got the right center, -3, 2, and he's going to the right. So that one is A. And then the last one, let me grab this one. Bring it down here, maybe. We've got 1x plus 3 squared. Y minus 2. Now, what are you supposed to do? You're supposed to get the x squared part alone. Well, it already is. It already is. That's nice. So what's the center? Opposite, opposite. Right? Opposite of -3. Opposite of plus 3 is -3. Opposite of -2 is plus 2. Center is -3 plus 2. Well, we know which one. You think we only got one left. I know, but I'm just proving it. -3 plus 2, that's right. And does it go up, down, right, or left? Well, the right side is positive y to the first. Positive y to the first. Where's the positive y direction? Up. It has to go up. Right? First power letter tells the direction. Positive y, up. Sure enough, positive y, up. That's it. And you think, yeah, it's the last one. I know. Last one to be sure. There it is. All things are right. There we go.